I'm Anil Kumar. As you know, graph of any quadratic equation will be a parabola. We will now understand how to sketch graph of y equals to ax square plus b. So I'll take different variations of this particular equation. Let me say we'll take y equals to, we'll take value of a as 1 and b as 0 to begin with. So that is y equals to x square. So in this case, a equals to 1 and b equals to 0. And then we will sketch y equals to 2 times x square minus 1, right? So in this case, as you can see, a is 2 and b is minus 1. And then we'll take few more variations. So when we are given an equation of the form y equals to x square, the graph will be a parabola, right? That's the shape of the graph. In this case, vertex will be at the origin, which is 0, 0. That gives you axis of symmetry will be at x equals to 0, right? And in this, most important is steps. Steps for y equals to x squared will be 1, 3, 5, 7, and so on. So that is the information which we have directly from the equation itself. Now let's sketch a graph based on this function. One more information we have, that is, since this coefficient is positive, it opens upwards, right? So it opens upwards. So you always begin with the vertex, which is at origin in this case. So that's the vertex. The origin axis is x equals to 0. That means the axis is y-axis, correct? So that becomes the axis for the given graph. Steps are 1, 3, 5, 7. What does that mean? It means that if you move 1 unit to the right, you have to go 1 in the direction of opening. Direction of opening is upwards. So we move, if I step 1 on the side, then I move 1 upwards. So this is my 1, right? So this is 1. Next time, when I step the second time, 1 on the right, then I move 3 up. That means 1, 2, 3. Do you see that? So you come at the value of 4, right? So this is 1 for us and this is 4 for us. Okay. And next time, when you move another step to the right, you move 7 up, right? So if you go 1, 2, 3, 4, 5, 6, 7, kind of, you can reach there. So these are the points. We got 4 of these points, starting with the vertex on the right side. These points can be connected to sketch the graph. So let me just connect these points now. So we have one side of the graph which is kind of like this. Do you see that, right? On the other side, we know axis is at x equals to 0. Every point can be reflected and you can get the points on the other side. Do you see that? So this distance being same as, you can treat this as your mirror, right? And reflect them to this side. So you get these points reflected and then you can draw that half of the parabola also, right? Joining all these points, which I didn't do so well. But anyway, you understand how to sketch it. So that becomes the graph of y equals to x square, right? So that is how you should do it. Let me take another example and I hope it is more accurate that time. So we have this y equals to 2x square minus 1. Now for this particular graph, can you tell me what is the vertex? Let's write it down, right? So we have vertex in this case as, now the a value. If I put x equals to 0, so this part will be 0, right? And b value gives the y value, which is minus 1. So in this case, the vertex will be 0, minus 1. Axis is the x value of the vertex, which is x equals to 0. Steps in this case are 2 times 1, 3, 5, 7, and so on, which are positive, right? And let me write down opens upwards, right? The steps also show you the direction. If it is positive, it is going upwards. Since 2 is positive, we say opens upwards. Okay. So based on this, we'll now sketch the parabola from this given equation, right? Okay. Now in this particular case, again, the vertex is at 0, minus 1. You'd always start with the vertex, okay? 0, minus 1. So this is 0 for us. Minus 1 is one step down. So we're just putting this point as minus 1. That becomes the vertex for us, right? So let me write down, show my scale here. So kind of like this, okay. 1, 2, 3, 4, 5, 6. Okay. So that is the beginning always for any parabola. It is opening upwards. Steps are 2 times 1, 3, 5, 7. That is to say, if I step 1 unit to the right, I have to go 2 times 1, which is 2 units up. So 1 unit right, 2 units up. That's my next point, okay? Then next step will be 2 times 3, 6. 1 unit to the right, 6 up. 1, 2, 3, 4, 5, 6. So that is my next step. Axis of symmetry is x equals to 0. Reflect all these points to the other side, right? So we get these points here. And then from here, 2 steps at the level of this, right? So we'll be here. Join these points to get your graph. So we have a graph which looks like a parabola. That is the vertex. It has to turn. That's a smooth turn and then go upwards, right? So that is how you could sketch y equals to 2x squared minus 1. Now let me take an example where the graph opens downwards. And this time I will make it wider. So when we do times 2, it becomes narrower. You can compare these two graphs. This is much narrower than the other one. Since in this graph we have vertical stretch, by factor of 2. You'll also notice that it is translated 1 unit down, and it is 1 unit down, right? So these are the two modifications, or I should say transformations, which have taken place if you compare it with the original graph y equals to x squared. Now I'll take up an equation where the value of a is negative. Let's take negative half, right, times x squared, and I'll take b as positive just to give you some variety. So we'll take this as let's say 2. Okay. Now since we know this graph will open downwards, so I'll have an axis which is kind of slightly over this, because we have to get points which will be below the x-axis, most of them. Okay. So let this be our coordinate axis, x and y, and as we did, we'll this time mark the scale first. Okay. My drawings are approximate, just to give you an idea how to sketch. You should always be sketching on a graph paper so that you get more accurate results. Now can you help me find the vertex in this particular case? So I'll write down all the parameters here. In this case, vertex will be at, if I put x equals to 0, this part will be 0 and y value will be 2. Vertex here is 0, 2. Axis is at the x value of the vertex, which is x equals to 0, and it opens downwards. Since this is negative, opens downwards, and the steps in this case are minus half. So you write minus half times 1, 3, 5, 7 and all, correct? Okay. So that means the first step is minus half. When you multiply, minus half means opens downwards. Do you get the idea? So these two are related kind of. Okay. Now let's begin with the vertex itself. Vertex is 0, 2. That means here. And that is the y-intercept also for the graph. Now the steps are minus half, first step. So if I go 1 unit to the right, I just move half unit down, right? So I can do left also and move half unit. From symmetry, you see these 2 points will be symmetrical. Now the next step will be for x equals to 2. So we move here, and this is half of 3, right? That is 1.5. So from here, if I go 1.5 down, I will reach at the x-axis, correct? So that becomes the second point. When reflected, you get on the other side also, right? That this is a reflected second point. And you can see this parabola is opening downwards and it is wider than the previous ones. Next step is half of 5, which is 2.5. So one step to the right, 1, 2.5. Next step to the left, 1, 2.5. So we get another step here. We can join all these points to get the parabola. So it has a curve which is always kind of like this. Don't make a corner here. That is kind of important to understand. And then connect these points. Okay, so then connect these points. Okay, so you get your parabola which represents minus half x squared plus 2. Now as an exercise, help me to write down the transformations of the graph of this function when you compare with the original function y equals to x squared. Okay, so let's do them one by one. So what do you understand? First one, where you see it is reflected on x-axis. It is kind of moving downwards. So we call that reflected on x-axis. You also notice it has moved up. So we say translated 2 units up, right? You're comparing with this one. And vertically it becomes wider, right? So we say vertically compressed by a factor. Factor means multiplied by. Factors multiplied. So steps are multiplied. You see that by a factor of half, right? So these are the changes which have happened to the original function y equals to x squared. I hope with this you understand in general how to graph a quadratic equation, especially when we are changing it vertically, when we say transforming it, or we can say transformation is vertical. So in all these examples which we have considered, what has changed vertically. Horizontally, the vertex remains on the y-axis. It hasn't moved, and the reason is that this term here is just x squared. It is not x plus or minus anything squared. So if x term remains as x squared, it does not change to x plus or minus. For example, if we'll take that in the next video. If I change x with, let us say, p, let me write another term here, square, then this makes a horizontal change. In our case, there was no translation, horizontal, correct? Therefore, we found that the vertex was always on the y-axis. Now, in the next video, we'll consider what happens when the term x changes to x plus minus p, okay? So that we'll consider in the next video. I hope the very basic concept of transforming a quadratic equation vertically has been clearly understood. I'm Anil Kumar. In case there are any doubts, please do write your comments. Share my videos and subscribe. Thank you and all the best.